Thank you. So I'm going to continue what the first presentation about measuring. Now, what could we do with this measurement? So this presentation will explain a study we did with end users, where we try to show them their energy consumption in real time and to study their behavior. What do they do with this metric? Did we manage to raise their awareness? Did they change their behavior in terms of using software in a desktop environment? So a little bit about me. I'm an associate professor in University of Pau. And I work on green IT since many years ago in software engineering and autonomic computing. And the context of this study, because I work a lot on software measurement tools and factors impacting software energy, so really from the software engineering community. And in this community, we tend to develop technical solutions, optimizations. We tend to, maybe when we include a human in the loop, it's always a developer or a system administrator. But we rarely involve end users in optimizing our software and their energy impact. And I think the next shift should be including these end users and pushing them to change their behavior. So using software differently or a different set of software. And to be able to do so, we need end users to understand the impact of software. Because I can ask you a question, what is software? What is software energy? Just a simple question like this. For anyone who is not technical or tech-savvy people, it is difficult to understand that an abstract concept like an idea, like an instruction, like a software, have an impact on energy consumption. So our question was, if we raise the energy, the user awareness in terms of energy consumption of software through live feedback, live screen feedback, and I'll show you an example of this feedback, will this push end users to change their behavior in using software? So we need to understand what do they know about software energy, what is their perception in general about software and energy, and will this feedback push to a behavioral change? So what we did is, in software engineering, it's a first of its kind study because we did a full, what we call quantitative study with a control group with 100 users. And we wanted to study the short-term behavioral change of end users. So in a 2-hour session of monitoring. And we collected through a survey their perception and their user awareness after the experiment. So what I mean by a visual feedback is this particular tool. So they had to install a few software, including this feedback tool, which shows 3 metrics. So the power consumption in watts at the lower end, the equivalent in price, and the equivalent in CO2 emissions. But we also showed a visual graph, which is an evolving chart, so end users can see if there is any spike in energy consumption. And we wanted to see which of these metrics or this visual feedback is more useful for pushing behavioral change. So we had roughly 100 users, so half of them were in the control group, which they didn't have this visual feedback. They were mostly computer science students in the final year, a third female, 2/3 males. But we had the same distribution between the control group and the treatment group. And they had us to do the similar workload. So everyone had a research project to do during a 2-hour session in class using online resources. And we collected metrics. We collected power consumption for everyone, CO2 emission, electricity cost, but also which software they were using and which was the active window. So we can observe if they change the software or change the window or do something else. And the treatment group, the one with the visual feedback, had to install the visual feedback too. We also had a questionnaire at the end where we collected the perception, what they about the experiment, about the software they used, which one consumed, in their opinion most of the energy, so they had to rate multiple software. And for the treatment group, the perception of the visual feedback. Was it useful? Was it annoying? So this is our experimental methodology. Basically, we had to ask them if they want to participate or not, because they could decline. And if they accepted, they had a guide to install all the tools. So they knew what they were going to do. And depending which group they were in, they had to install a few additional software and then fill the questionnaire and then send us back the data. So they could check at the end the data. Okay, so when we did all of this, we ended up with 52 valid data out of the 95, 26 of each group, and so the results are based on this data. The majority were on Windows with Intel processors, and yeah. So what did we learn from this experiment? The first observation is that users tend to underestimate their energy consumption, whether in treatment group or the control group. We also observed that these were computer science students, so for them the operating system was the main culprit, and they think it's the most consuming energy. And we attribute that to lagging in the operating system. They had a lot of software installed and used at the same time, so they perceive that if it's slow, it means it's consuming more energy. Also, all the programming and like Eclipse, IDE, or all the programming tools and communication program like Zoom or Teams are also perceived as high consuming because they use a lot of RAM, they lag on the machine. But they understand that the energy consumption is not just on their device, because they were using online resources, that all the cloud infrastructure have a big impact on energy consumption. Regarding the feedback, we observed that it was helpful. They were aware that they are consuming energy. They saw that sometimes there is a spike in energy consumption. But it was quite distracting, this visual tool, because they couldn't minimize it, they couldn't close it. It was always on at the bottom of their screen. For them, also the metaphor, the chart, the evolving chart was more useful because we observed a few users trying to change their behavior when there is a spike in energy consumption, rather than when the chart was flat. And the most important lessons is that they resist any change when they were doing important tasks. So mainly at the end of the session, when they had to give back their workload, their classes, I mean the report they had written, they didn't care if there is a spike or not. And most importantly for us is, even when they tried to change their behavior, they didn't know what to do. And well, I have a couple of graphs, they don't show much, but what we see here is that some people stated they changed their behavior when there is a spike in energy consumption. Here we see the spikes of energy consumption. And when we observe what they did, sometimes they just minimize the window, they switch from Chrome to another software, but it didn't have any impact on energy consumption. So all the actions they try to apply have no impact on software energy consumption, unfortunately. So what we can conclude is the feedback is useful to raise awareness. The feedback is useful to let people want to change behavior, but they don't know what to do. They need guidance. We need to tell them that, okay, now you use a lot of energy in this software, you need to change software or to use it differently. So they lack this knowledge to apply these software behavioral changes. And obviously that they resist any change if the perceived workload is very important for them. That's why they don't care about energy. So what we're aiming for in the future, this is the last slide, we want to study additional metrics, additional metaphors, because here we had only 3 metrics and 1 metaphor. And more importantly, we want to produce some guides and techniques to help users to understand what to do, and we want to automate these recommendations. And this is what we're trying to do with the Behave project, which we started recently. If you're interested, you have the website. We just started a few months ago. Thank you.
Thank you. Okay, so now I get a bonus point because there's a connection here between the non-negotiable behavior of this important work. They don't care about the energy consumption, and playing computer games in the Malmödin household is also non-negotiable. Just one more reflection, actually. You said that when it sort of gives them feedback that they use a lot of energy, they don't know what to do. When I was a student, I know what I would have done. I would have turned off the computer